How can electrical engineers understand complex FFT output easily? Imagine trying to read a map with countless roads and intersections. It can be confusing at first, but once you understand the key landmarks, navigation becomes simple. That's how understanding complex fast Fourier transform outputs works for electrical engineers. The FFT is a tool that transforms signals from the time domain into the frequency domain, revealing what frequencies are present in a signal. It's like turning a complicated sound into a clear list of notes. To make sense of the output, engineers need to know what the FFT is doing behind the scenes. The FFT breaks down a signal into its basic frequency components, showing how strong each one is and how they relate in phase. The output includes both amplitude, which tells you how loud each frequency is, and phase, which shows the timing of each frequency relative to others. When looking at the FFT output, you'll see a spectrum that shows positive and negative frequencies. Usually, engineers focus on the positive side by creating a single-sided spectrum, which simplifies analysis. Sometimes, the peaks in the spectrum aren't very sharp because of the way the FFT works. This is called spectral leakage, and it happens when the input frequency doesn't match exactly with the FFT's frequency bins. To fix this, engineers use window functions, which smooth out the signal before transforming it. The resolution of the FFT depends on how long the input signal is. A longer signal gives a finer frequency resolution, making it easier to distinguish close frequencies. In practical terms, if you want to analyze electrical signals in control systems or digital signal processing, understanding these concepts helps you interpret the output quickly. For example, in power quality analysis, FFT reveals harmonic distortion, which can cause equipment problems. In vibration analysis, it helps identify resonant frequencies that might damage machinery. By learning how to interpret the amplitude and phase data, and understanding the effects of windowing and resolution, electrical engineers can decode complex FFT outputs with confidence. Think of it as learning to read a musical score. Once you know what to look for, the music becomes clear and easy to follow. With practice, analyzing FFT results becomes second nature, making signal processing tasks more straightforward and efficient.